All right, let's take a look at the first page of problems for sludge pumping and thickening in Chapter 5. I'm going to start with an example similar to problems number 1 and 2. This is asking for the percent total solids of sludge. So before I show you how to do the problem, let me explain to you how this test is done in a lab. And basically what we're doing here is we're collecting samples of sludge and we put them in a dish and then we put that dish in a drying oven overnight. Temperature, I believe, is 104 degrees Celsius. All the water from that sludge sample will evaporate, and then we'll weigh what's left over, and that determines what percent of that sample is actually solids. So, simple answer on how to do this problem is to divide the leftover, so 0.56 grams in this case, divided by the initial weight of the sample, which in this case was 14 grams. So let's go ahead and do that division. 0.56 divided by 14 comes out to 0.04. And then because they're asking me for percent total solids, I have to convert that into a percentage. And I do that by multiplying, of course, by 100. And I get 4%. Now, I'm not sure how this problem is going to be presented on an exam, but in the lab, as I mentioned, the first thing that we have to do is weigh the dish. So you may see a problem that looks like this. The weight of the dish by itself is 20 grams. And then the weight of the dish plus sample then would be 34 grams. And then you would be given the weight of the dish plus the dried sample. And that, of course, would be 20.56 grams. So if you see this in a word problem on an exam, you may need to account for the weight of the dish. So, of course, you would subtract the weight of the dish from the weight of the dish and the initial sample to get the weight of your initial sample. And then you would have to subtract the weight of the dish from the dried sample to get the weight of the dried sample. But that is how you do the problem. So divide the weight of the finished sample by by your beginning weight, and you would get 4%. If you forget that, if you actually did the percent removal equation that I just showed you, the in minus the out times the in. So let's say you said, oh, I know, percent removal. 14 minus 0.56 divided by 14. You're going to wind up with 0.96 or 96%. Well, if you think about it, you've just calculated the percent removal of the water. So if you've removed that much water, then what's left over is going to be sludge. You could actually, at this point, subtract 96% from 100%, and you're left over with 4%. You can still get to the right answer if you use that equation. So simple equation up here. If you're taking a test and you set it up wrong, remember, read the question. It should be, pretty intuitive to you that if it weighed 14 grams when you started and less than a gram when you ended, then the percent total solids should be pretty low. So if you come up with a number like 96%, then hopefully you go, oh, well, that's not logical, but 4% is, as far as what's left over. Okay, this next problem, kind of a weird one that I don't know has any real life application. I mean, we can measure gallons of sludge all day and convert that to pounds. I don't know how you measure pounds per day of sludge removed and then try to convert that to gallons. But in any event, we're given 700 pounds per day, solids content of 3.75%, and the specific gravity being 1. So this is pretty simple if you think about it. We have 700 pounds of sludge, and if 3.75% of that is solids material, divide the pounds of sludge by the percent solids. And now you do have to convert that to a decimal. So if I divide 700 by 0.0375, I get the total pounds of sludge, 18,667 pounds. So hopefully you understand that. If 700 pounds per day are removed, and that 700 pounds has a solids content of 3.75%, and this question, of course, is not really all that well written, because I would take 700 pounds a day of suspended solids just to include solid material and not, but in any event, I would have written the problem 700 pounds per day of sludge. So, in any event, not a well-written question, but that's what they're asking for. 700 pounds per day of sludge divided by the percent solids is going to give you pounds of sludge. And now that we know the pounds of sludge, we can divide that by the weight of a gallon of water to determine how many gallons that is. Right? We know that there are 8.34 pounds per gallon of water, and we can use that figure because the specific gravity is 1. So 18,667 divided by 8.34 lets us know that we had approximately 2,238 gallons of sludge that were removed. So again, not really great the way the problem is written, I don't think, but that's how to set it up and think about it and how to do the calculation to get the answer that they're looking for. So given pounds of sludge and percent solids, you can use that information to determine gallons. And that would be pretty much the same for questions 3 and 4. So hope that helps.